we will start the session right now. I hope so that I am audible and I hope so that I am visible. Yes, I am audible as well as I am visible, both. Yep. So guys, welcome back to Coders Arcade. This is Ashank David, and in today's video, in today's live session, we are going to talk about the final topic. In the graphs concept, we are going to talk about one of the final concepts, one of the algorithms which is very important for all of us to understand, and that is Prim's algorithm. What is Prim's algorithms? So guys, this is Ashank David. Let's start this YouTube live session. And we'll conclude the DSA concepts in this video because we saw that the engagement on the videos are coming a little bit less. So we thought that okay, now on demand, whatever videos will be coming on, we will posting them separately in the same playlist. So I'll be concluding this playlist today, guys. Today is the last video of this playlist, this series of DSA live session. So welcome back to it. And this is Ashank David. Let's start. Before I start with this video, guys, I would like to request you people to please like, share and subscribe to our channel, and don't forget to press the bell icon also so that you won't miss any future updates. Also share this live stream as much as possible to so many viewers so that so many viewers can also see us at the same time. Those people who need to learn about DSA and all for free, they can also join us. This is Ashank David. Let's sign in into this concept and let's start our main concept for today, and that is gonna be our graphs. We were talking about graphs here. We were talking about graphs as we have already seen before that we were doing graphs data structure, and in graphs we have finished up Dijkstra's algorithm yesterday. Now in today's class we will be doing the Prim's algorithm. Prim's algorithm. Guys, this algorithm is one of the important algorithms in graphs. If you want to understand about graphs, if you are learning or preparing for placements in graphs, you have to learn this concept. It's a very important concept, and in this concept we talk about what does the Prim's algorithm do. It allows us to find the MST. What does this MST means? MST stands for minimum spanning tree, guys. Okay, minimum spanning tree. If you don't know what is minimum spanning tree, you are on the right spot. I am going to explain you what is minimum spanning tree. Say for example, you have a graph. I am saying that you have a graph. Let us say our graph is gonna be this one. I have my graphs here. So let us say our graph is this one. This is 0, this is 1, then this is 3, then this is 4, then this is 2, like this we are doing. Let us say this is our graph. This is our graph, guys. Now there are some weights put it onto it. For example, here we have 6, this is 2, this is 8, this is 3, this is 5, and this is 7. Alright guys, so let us say we have this graph. We have this graph, and in this graph, if you want to find minimum spanning tree, MST, you have to find MST. First of all, you need to understand what is MST. MST stands for minimum spanning tree. And what is minimum spanning tree? Graph is V comma E, right? What is a graph? Graph is V comma E, where this is vertices and this is edges. In any graph, the number of nodes will be, let's say for example in this graph, how many nodes are there? 1, 2, 3, 4, 5. So nodes are equals to 5 and edges are equals to 1, 2, 3, 4, 5, 6. 6. Correct guys? 6. Here you see this is the current number of nodes and edges in this graph, right? Now if I say that what is its MST, if I want to find its MST, MST is always number of nodes will be the same, n will be equals to 5, but edges will become n minus 1. Edges will become n minus 1, means 5 minus 1, which is equals to 4. So basically if you want to see what is an MST, this is n minus 1, that means 5 minus 1 equals to 4. So in this case, if you have number of nodes same and edges is equals to node minus 1, that means 1 lesser than the number of nodes, then that diagram or that kind of tree will be called as minimum spanning tree. Just not minimum, just a spanning tree. Okay. For example, if we try to make, say for example, if we try to make the spanning tree of this, then there can be two spanning trees created, like many spanning tree can be created. For example, I can create a spanning tree, I will write a spanning tree of this graph. Let us say we will create one spanning tree like this, where the number of nodes are same. You will draw the number of nodes exactly the same, 3 and this is 4, okay. This is 6, 2, 8, 3. The weights are given like this: 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay guys, I guess this is 3. This is not 8, but this is 3 actually. This should be 3. Okay. So how much? 6, 7, 8, 9, 10, 11, 12, 13, 14. Understood this guys? Or, oh wait, this is not 8. This is 5 I guess. Yes, this is 5. Yes, this is 5. So now 5, 6, we have 11, 12, 13, 14, 15, 16. So you see, add up all the weights here. Sum is coming as equals to 16. Okay. Now I said, now we have, this is one of the spanning tree. Okay, this is what? One of the spanning tree. Now in this case, if we create another spanning tree, here for example, if we create one more spanning tree, then it will be 0. Let us say the number of nodes will be the same, of course, but there will be number of edges will be reducing. So in this case, let us say this is 3 and this is 4. Alright guys, this is 4. What is the edges here? Wait, 2, 3, 8 and this is 7. What is the total sum here in this case? Here the sum is coming as 20. So guys, now you see here, this was our graph, What did I tell? Minimum spanning tree is the number of nodes same, n will be equals to correct n, and edges will become n minus 1. Understood my point? This is the basic formula of finding the MST. So in this case, number of nodes are same, that is 5. This is also 5. But here we have changed the connections. Basically, here the nodes are connected with each other. Every node is reachable from every node, and here there are 4 edges in this case. So this is a spanning tree. This is also a spanning tree. But you see that the sum of the weights in this graph is coming as 16. Understood my point? But in here the sum of the weights are coming as 20 here. You create any other graph, you create any other possible spanning tree, your weight will not come as less than 16. 16 is the smallest. So this is gonna be, we are calling this as MST. This one is the MST. Understood my point? but this one is not an MST. This one is not an MST because there is no, it is a spanning tree. This one is a spanning tree. I'll write it here actually, MST. This is not a minimum spanning tree, but it is just a spanning tree. It is what? It is just a spanning tree, but not a minimum spanning tree, guys. Remember this always. But this is the minimum spanning tree. So this tells us the definition of minimum spanning tree. Minimum spanning tree means the tree which has the same number of nodes but edges one lesser than the node, and every node is reachable from any other node, and the weights on the node is minimum among all the spanning trees. That spanning tree is called as minimum spanning tree, guys. I hope so that this is very much clear to all of you guys. And Prim's algorithm, which I am talking about in this video, is used to find the minimum spanning tree of a graph. I hope so that this is absolutely clear to all of you. This is a very important concept, and that is why I have came in this class with this concept for you guys, because this is a very commonly asked question, guys. I hope so that this is very much clear to all of you. This part of minimum spanning tree is absolutely clear to everyone. Okay, guys. Now moving back to our Prim's algorithm for the minimum spanning tree, let's take up one more example and understand how we can create a tree, a minimum spanning tree using this equation. Okay, so basically I'm gonna create one graph. So for example, here this is our graph. Let us say we have a graph, this 0, 1, this is 2, this is 2, and let us not make this as too long. This is gonna be 3, this is gonna be 1, and let us say this is gonna be 4. This is gonna connect with this is gonna connect with this, and this is gonna connect with this. Let us say this is our graph, and here 1, this is 1, this is 2, this is 2, this is 1. Or actually let us make this as 2. Okay, so 2, 2, 2, and then 1, 1, and here also 1. Okay. Alright, guys. Now you have this, guys. You have this graph, and this graph, this is the graph where you have to apply Prim's algorithm. Let us try to apply Prim's algorithm, guys, in this question, in this graph. How do we apply Prim's algorithm? First of all, we will talk about what are the requirements. The major number one